Hello everyone, welcome to my second video. So here I am going to talk about object classification and object detection, which are very common problems in the field of artificial intelligence, machine learning, or computer vision to be specific. Object classification, or the more generic term, object detection. So let's start with the simpler term over here, which is object classification. So say you have been given an image and there is a cute cat in it, and you pass it through a neural network, which is basically a model which is used for machine learning and artificial intelligence, and you ask this model, can you tell me whether the picture that I gave you is of a cat? And what does this model tell you? That yeah, I am say 75% sure that yeah, this is a cat. Cool. This is object classification. Say you're passing in the pictures of an aeroplane, or you're passing in a picture of a dog, and you just ask, can you classify it? Can you tell me whether the picture is of a dog or a cat or an airplane? And this problem is the problem of object classification. But we can generalize it. Here we are assuming that the entire picture is classified to be that of one particular object or one particular type, whether it be a cat or dog or an airplane. But what if we have multiple cats and dogs in a frame? Right? You visited a farm or a pet house, and you found that there are many cats and there are dogs as well. Over here you can't ask the network just that whether is the picture of a cat. You want to know, for example, how many cats or how many dogs are there in this image, and we want all of them to be identified. For example, like you ask the model, can you tell me, if I give you this image, how many dogs are there in this picture? And the model is supposed to tell you, yeah, there is a dog, there is a dog, and there is a dog. This is object detection. So basically, detection is classification plus localization. What does localization mean? It means you have to tell where in the image is a dog. This principle is also used in face recognition, face detection. When you're trying to click pictures with your absolutely updated smartphones, and you see that inside the view of a picture, if several people are standing, you will see so many boxes around their faces. So there is a model inside which is trying to do object detection. Basically faces. The face is an object, the human face. That's why it's called face detection. But now we want to come to the important question. How can you tell whether this model is actually doing good object detection or bad object detection? There has to be a quantifiable metric to tell us these things. In the world of machine learning and object classification and detection, fortunately we have such metrics, but it's often very confusing to understand. And therefore the goal of this video is to clarify these concepts. For example, let's assume that we have a picture and we have say 7 dogs in it, And say we have like 5 cats in this picture. Okay, and we ask or we want to know how many dogs are there in this picture, or detect, identify all the dogs in this picture. Correct? So ideally what we want to do is have boxes around all of these dogs, right? But say our model tells us that it was able to identify 7 dogs. It said this is a dog, this is a dog, this is a dog, this is a dog, this. So our model thinks that these 7 are actually dogs. But we can see that it has done something mistake. Some mistakes are there in this particular classification. For example, it has not correctly identified all the dogs. It has by mistake identified some cats as dogs. How do you quantify it? Thus we go to the metrics of classification and detection. Let's talk about true positives. Before we actually dive into that, we can also talk about what are positives and negatives. The model was able to tell us that these detections are there. It did not identify any other animal. It did not even tell that these are animals over here. It just found out these. So it missed out on all of these and it identified these. So these are called as positives, the detections that were identified. And the ones that were missed are called negatives. Now, what is a true positive? These detections, this one, this one, this one, and this one, these were actually dogs and they got identified also as dogs. So they are true positives. How many true positives do we have over here? We have 4. Now there is something called as false positive. Again, what is positive? The model has identified it, but we only wanted to identify dogs. But the model has by mistake identified some cats as dogs. So it is a false positive. How many false positives do we have? We have 1, 2, and 3. Similarly, we have something as true negative. Now all of these animals over here have not been detected at all. Those are negatives. Cool. But we did not want to identify only the cats. So if a cat has been left out, it has been correctly classified as a negative. How many such cats do we see? 1 and 2. And then there is something called false negative. What is a false negative? Something that is a negative that was failed to be identified, but it was wrongly done so. We wanted to identify all the dogs, but we couldn't identify this dog and this dog as well as this dog. So basically there were 3 dogs that were not detected, but they should have been detected. So those are false negatives. They are negatives because they were not detected, but they were falsely done. So it was a mistake. We should have identified those. Our model should have done that. How many of them are there? 1, 2, and 3. From here we derive the very popular metrics of object detection and classification known as precision and recall. Now what is precision? You were able to identify 4 dogs, right? 1, 2, 3 and 4. But how many total things that were you able to identify? 1, 2, 3, 4, 5, 6, 7. So you're making 7 detections, but out of them only 4 are correct. This is basically precision, which is true positive divided by true positive plus false positive. This tells you what is the quality of your detections. You are doing detections, but what is the quality? You are detecting both cats and dogs. That is not satisfiable for us. We wanted to identify only the dogs, right? So what is the quality of our detections? Just doing the detections is not enough. How precise is the quality of your detections? That is given by precision. But this alone is not enough. Why? Because you can already see that some dogs were missed out. So even if you are able to identify dogs, but not all of them, that doesn't mean that your model is doing good. You have missed out on so many. How do you capture that in a metric? That is what is called recall. How many dogs were you able to identify? 4. But how many total number of dogs were there? 1, 2, 3, 4, 5, 6. 6 dogs, right? 1, 2, 3, 4, 5, 6, 7 dogs. Again, the recall is true positive divided by true positive, the ones that you identified, but there are some that you missed, the false negatives. You misidentified these dogs that you wanted to identify. It is never the case that you will only depend on precision or recall. You want both of them to be high for your model. Over here, it means that you are able to do a correct detection. You are identifying dogs and not cats. And this basically means that you are identifying all the dogs. But it doesn't mean that you have identified all the dogs, but you have identified cats also as dogs. Then you will be having a high recall, but a low precision. You want both of them to be high. Thus comes a score which is known as the F1 score, which is a combination of both of these two. A harmonic mean, the formula is 2 into precision into recall divided by precision plus recall. It takes into account both precision and recall and gives us a unified metric for judging a model's performance. Suppose you have a perfect precision and a perfect recall. Then what will be the value of this F1 score? 2 into 1 into 1, 1 plus 1. This is 1. The goal of every object classification or object detection model is to achieve a perfect F1 score. If your model is achieving, obviously this is very difficult to achieve, and we try to achieve 1. If we have a 90% or 95%, I mean that is generally considered quite good. And the higher is the F1 score for your model, the better it is at classifying and detecting objects. I hope I could make this slightly confusing concept a little more clear to you, and I hope you enjoyed and liked this video, and please stay tuned for future videos. Thank you.